Working with decimals is one of the fundamental skills you need for the GRE. Let's say you get a fraction like 2/5, and you need to know what 2/5 is as a decimal. Well, that's easy. You can just put it in the calculator. 2 divided by 5. And the calculator will tell you that that is 0.4. But working in reverse, taking 0.4 and making it a fraction is a much harder skill. All of the decimals we've seen so far are called terminating decimals because they terminate or end at a single point. So something like 0.4 terminates in the tenths place at 4, or 0.25 in the hundredths, 0.375 in the thousandths place. All of these finish at one point. They're terminating decimals. But you could see what we call non-terminating decimals. And a common example of this is something like 1/3. 1/3 is 0.333 repeating. These threes go on forever. In fact, you might see this as something like 0.3 with a little line over it. Now, we could also call 1/3 a rational number because I can express it as one integer value over another. You might see non-terminating decimals as irrational numbers, something like the square root of 2, or even the square root of any non-perfect square, which is 1.414213, and so on. It never makes sense the way that 0.3 does. Now, whether you're dealing with terminating or non-terminating decimals, converting fractions into decimals is easy, right? Just take 1 divided by 3, put it in your calculator, and listen to the answer it gives you. For the reverse, with terminating decimals, all I do is I go to the tenths or the hundredths or the thousandths place, whatever the final place is, and rewrite that value as a fraction, so 375 over 1,000, and reduce it into its simplest form. To convert decimals into fractions, we can't really rely on our calculators. We have to remember place value, or the names of the digits. Let's take a look at that last example we did, 0.4. What I want to do is go to the final digit place, this 4, and say, well, what do we call this? We call it tenths. And that means that what I'm really dealing with is a fraction of 4 over 10. And from here, I can reduce this. I can say, well, what divides evenly into 4 and 10? And that will reduce down to 2/5. It works the same way with even longer decimals, like 0.25, right? Go to the final place, the 5, and say, well, what place is that in? It's the hundredths place. So I can rewrite this as 25 over 100. And now the calculator could play a role, right? I could divide 25 into the first number once, and 25 into the denominator 4 times, and get 1/4. Let's try it with a 3-digit number. I'll go to the final digit place, the 5. That's what we call the thousandths place. So I can rewrite this as 375 over 1,000. And then use the calculator again. Divide 5 into the numerator and denominator, or 25. And eventually, I'll get down to 3/8. So the trick here is just go to the final digit place, name it, the tenths, the hundredths, the thousandths, etc. Write out the larger fraction, and then reduce it down to its final form. Let's try a harder example. Let's say I have to convert the number 6.75 into a fraction. Now, the easiest way to approach a number greater than 1 is to deal with the decimal first and then the integer value. So let's take this 0.75. The 5 is in the hundredths place. So I can just rewrite this as 75 over 100. And now I can use my calculator or mental math to reduce. 25 goes into the numerator 3 times and into the denominator 4 times. So I get 3/4. Now what I need to do is get this 6, this whole number value, in terms of fourths. And the best way to do this is to just take 6 and multiply it by 4 over 4. This will keep the value the same because think about it, 4 over 4 is just 1, but it will give me a numerator and the denominator of 4. So I'll take 6 times 4 is 24 over 4. And that also makes sense because 4 goes into 24 6 times. Now what I want to do is combine the number I split. Take the 3/4, which is the decimal part, and add it to the whole number part. And now I have a simple fraction addition problem. Now remember, with adding fractions, if the denominators are the same, just add the numerators. That gets me 27 over 4. So I can say that 6.75 as a fraction is 27 over 4, because I dealt with the decimal first and then the whole number.